The next major branch of physics that we'll be studying is quantum mechanics. And as we studied previously in its definition, that it basically describes the behavior of matter and energy at very, very smallest scale, at the scale of atoms, electrons, photons, and where basically the classical physics fail, then quantum mechanics come at that point, right? So, wave particle duality. Why do we come over here? Basically, in the coming 2 minutes, we'll be studying about the foundational principles of quantum mechanics. So these are basically some of the foundational principles of quantum mechanics. The first thing is wave particle duality, that it was observed that particles exhibit both both the properties of wave and the properties of a particle. This is a very big topic, and but beyond the scope of this presentation. Okay, then we have the uncertainty principle that was presented by Heisenberg, and where he said that it is impossible to simultaneously know the exact position and the momentum of a particle. So that's one of the very big discovery that Heisenberg made. Then we have superposition, where it was said that a quantum system can exist in multiple states simultaneously until it is measured or observed. Then quantum entanglement phenomena, that two particles can be correlated instantly regardless of the distance between them. The equation of Schrodinger's equation, it is basically one of the fundamental equations governing the evolution of smallest quantum states over time, and quantization of energy. Energy levels in atoms are discrete; they are not continuous, and it was explored by it was basically explained by Neil Bohr in his model. So these were the foundation principles of quantum mechanics. Now going to the next major branch of physics, which is nuclear and particle physics. And as we saw earlier in its definition, that basically nuclear physics it studies the nuclei of atom, its structure, composition, its behavior, and basically the nuclear reactions it undergoes. So the core concepts in nuclear physics are the radioactive decay, the nuclear fission, fusion reactions, what is binding energy, and all of these topics. They basically they come in this nuclear physics category. And then we have particle physics, where basically it studies the fundamental constituents of matter and energy and the forces between them. So particle physics basically it answers the questions what everything is made of at the fundamental level, right? And these are some of the very major topics in this particle physics course in this category. All right. Then the next branch of physics is astrophysics and cosmology. These are also the major branches of physics, which basically deals astrophysics applies the laws of physics to understand stars, galaxies, and to understand the universe, the phenomena occurring over there. And cosmology basically studies the origin, structure, and ultimate fate of the cosmos. So then some of the key topics in astrophysics are stars and stellar evolution, the evolution of stars basically, where we study the life cycle of stars, its formation, hydrogen fusion on the main sequence, and then its expansion to becoming red giants and all of this. Then we have black holes, a very, very major topic, They are basically regions where the gravitational field is so intense that not even light can escape. The Big Bang, a theory which states that the universe began 13.8 billion years ago from an extremely hot dense state. And then we have these topics: dark matter, dark energy, and cosmic microwave breakdown, exoplanets, and thousands of planets outside our solar system have been discovered. So these are all the topics basically that we normally study under the astrophysics and cosmology, under this branch of physics. Okay, so moving forward now, we will be studying some other important branches of physics here. First of all, we have acoustics. So it is basically a branch of physics which deals with the study of sound waves, the production, transmission, reflection, and hearing of sound waves, how it occurs, its behavior, its nature. So this branch is basically used in music, in sonar systems, in medicine, ultrasound. Next, we have biophysics. So the biophysics branch applies the physical methods, the methods of physics, and its principles to understand different biological systems. For example, to understand how muscles contract and how the nerves transmit signals, the mechanics of DNA. So, all these things we study in biophysics. Next, we have medical physics. It is a little bit different from biophysics. How? I'll tell you. So, in this branch of physics, basically, we study the applications of physics in different medical fields, not just inside human body. For example, the application of physics in medicine for the purpose of diagnosis and treatment. It is therefore we use physics in the waves, in X-rays, CT scans, MRI, radiation therapy for cancer, nuclear medicine imaging. So moving forward, next we have geophysics, and this branch basically applies physics to study Earth, to study seismology, which is the study of earthquakes using seismic waves, the study of geomagnetism, basically the magnetic field of Earth, its origin and variations. We also study movement of water in Earth systems. We study weather, climate, and the behavior of atmosphere. We study about the physics of volcanic processes. And then we have solid state, or we can call it condensed matter. So one of the largest branch of contemporary physics, and it basically studies the physical properties of matter in condensed phases, solids and liquids. And the key areas in this field are semiconductors, superconductivity, magnetism, liquid crystals, nanomaterials. And moving forward, we have computational physics, where we use computers to simulate and solve complex physical problems that cannot be solved analytically. I'll give you a few examples, such as weather forecasting and climate modeling, n-body simulations of galaxies and dark matter, fluid dynamics simulations for aircraft and ship design, similarly, molecular dynamics simulations for drug discovery. So, all these topics we study it there in computational physics. Next, we have physics and modern technology. So, basically, every technology that shapes our modern world is built upon the discoveries of physics, right? So, this section basically illustrates the bridge between fundamental physics and practical technology. So, in quantum physics, basically, As we studied earlier, we study things at very small level, at atomic level. So the study of transistors, computers, smartphones, internet, all these are basically applications of quantum mechanics. And then electric motors, generators, radio and TV, all these things happening around, these are applications of electromagnetism branch. So here we are basically studying every branch and the applications that it is used in. Nuclear power plants and medical imaging is basically used in nuclear is an application of nuclear physics. Then the application of optics is in lasers, in fiber optic internet, camera sensors, and so on and so on. Right? Steam engines, jet engines, refrigerators. These are applications of thermodynamics. The application of acoustics are in sonar, ultrasound, noise cancelling headphones, and semiconductors, LEDs, solar panels. They all fall in this condensed matter category. So moving forward to the summary, and in summary, we can easily say that physics is at the base of everything. Physics is basically the foundation of everything, and physics is basically the science of matter, energy, space, and time. It uses maths at its primary language, and then we can divide it into two different eras: classical era and then the modern physics era, pre 1900 and post 1900 physics. Okay, so then we have the major branches of physics where we studied about mechanics, thermodynamics, optics, electromagnetism, quantum mechanics, quantum physics, sorry, nuclear physics, astrophysics, and then some of the applied branches such as biophysics, medical physics, geophysics, condensed matter, and all. So moving forward, then we have all modern technology that we have today, starting from smartphones to GPS, everything that we see, everything that we observe, it basically runs on physics. So that's all for this lecture. And in this lecture, we studied some of the very major branches of physics. Thank you.